Welcome everyone. In this video we are going to find the derivative of x raised to the power of x raised to the power of x with respect to x. We want to find the derivative of this guy. Now to start off, I will say that this is equal to y. So our question is basically, what is dy by dx? Cool. How do we start? Since we have a variable on the base and also on the exponent, it is a very good idea to start with logarithmic differentiation. That is, we take the natural logarithm of both sides. So we have ln of y and ln of the function that we want to find the derivative of with respect to x. So if we do that, on the left we will of course have ln y is equal to, on the right we can bring the exponent forward. This is a property of logarithms, which means we have x raised to the power of x, then ln of x. So far so good? Oops. Now I want to take the derivative with respect to x on both sides. When I take the derivative on the left, what do I get? Well, I have ln y, so I need to use chain rule. How do I use it? Well, I first take the derivative with respect to y. The derivative of ln y with respect to y is 1 over y times the chain rule tells us dy by dx is equal to. Here we see that we have a product of two functions. One function is x raised to the power of x, the other function is ln x. So we need to use the product rule, which I derived in a previous video. You can access it from the cards right now, also from the descriptions part. Using the product rule, we know that we need the derivative of the first function, so x raised to the power of x prime, times the second function, plus the derivative of the second function. So what is the derivative of ln x with respect to x? That would be 1 over x. Then we multiply this by the first function, which is x raised to the power of x. Alright. Here, only thing that is left for us to find is this guy. The derivative of x raised to the power of x with respect to x. And in a previous video, I found that derivative. You can access that from the cards right now and also from the descriptions part. Since I already did this on this channel, I don't want to take unnecessary time, so I'm just going to write that result from that video, which you can access, as I said. So the derivative of x raised to the power of x will be ln x plus 1 times x raised to the power of x. And then we will have the rest of it. So we will have ln x plus 1 over x, x raised to the power of x. And let me erase this equality sign. On the left we will have dy divided by dx 1 over. Now instead of y, I will write x raised to the power of x raised to the power of x. Because remember, right here at the beginning we defined x raised to the power of x raised to the power of x to be y. So we can substitute for y. Cool? Here, as I said right here, we want to solve for dy by dx, which means we just multiply both sides by x raised to the power of x raised to the power of x. I said x a lot in this video, but that's what we do, right? So, if we solve for dy over dx, then we get that dy over dx is equal to ln x plus 1 times x to the power of x times ln x plus 1 over x times x to the power of x, all of that multiplied by x raised to the power of x raised to the power of x. And this is the final result. If you would like, you can simplify this a little, but I'm not going to bother doing that because I already like the way it looks. If you have any questions, please write them in the comment section. I hope to see you in another video. Until then, take care.